Hi everybody, it's Miss Matzi. It's the end of the day, so I'm going to go over what we did in class today. Today is March 8th, 2018, and it's an A day. In class today, our main objective was I can observe the texture of igneous rocks in order to identify igneous rocks and infer their cooling environment. We had a packed agenda. We started with a review on the minerals vocabulary, and then the students, some students took the mineral quiz. Some students did not take the minerals quiz today because they had been absent the class before due to testing. Those students are going to be taking the quiz on Monday, so make sure that you're studying and you're ready for that. After everyone finished up the quiz, we took some notes on igneous rocks, and then we started the igneous rocks chart. Your homework is to log in to Google Classroom and re-look at the igneous rock notes and study them. Let's take another look at those notes. Here's one of the slides that we looked at about igneous rocks. This is showing you that igneous rocks are created from molten material. Now, that molten material could either be under the Earth's surface in the magma chamber, or it could be erupted out of a volcano. Where the molten material is and where the molten material cools and solidifies has everything to do with what the igneous rock ends up looking like. Here's a good example of that from your notes. You see example A has little tiny dots in it. You can see all of the different little minerals in it. And that's because example A cooled inside the earth in the magma chamber. It had a long time to cool because inside the earth in a magma chamber, when that starts to cool down, it's like the minerals are inside of a thermos, and it's going to take years and years and years for that magma chamber to cool down. And the slow cooling really gives the minerals a good chance to grow out and to grow large. Whereas when you look over here at example B, you can't see any individual minerals. This is considered fine-grained. And so what you can infer from that is that this was erupted out of a volcano. This formed very quickly as it was erupted from a volcano. Don't forget to take some time to go through each of the specific rock types like rhyolite, pumice, and granite. There were 9 rocks altogether that we looked at. We looked at rhyolite, granite, andesite, diorite, basalt, gabbro, pumice, obsidian, and scoria. Those are the 9 igneous rocks that we're learning about right now. We didn't get to look in the lab yet, so on A day, because we were a little bit behind, we only got to look at the chart. But next class, on Monday, we're going to take some time looking at those 9 igneous rocks that I just mentioned. Rocks like basalt and granite and pumice. Pumice is the really light rock with the vesicular texture with lots of air bubbles in it. It has all these air bubbles because it was erupted really quickly out of a volcano. So we have this igneous rock lab, identification lab, to look forward to on Monday. A couple of reminders. I'm noticing in the gradebook that students are still missing their forecast sheets. That's a 24-point assignment. So if you have not turned that in yet, you want to finish it up and turn it in, or just turn in whatever it is that you happen to have finished in class. The other thing that I'm noticing is that a lot of students are missing the evaluation sheet core content, and that looks like this right here. It was a study guide in the weather unit. So this is another thing when you look through your notebook or your folder, you probably have this partially started because we did start it in class. You want to finish it up and pass it in. That's all for today. Have a great afternoon, and I will see you on Monday.